Okay, the second most colourful stone that I can think, well, mineral actually, that I can think of is actually not meant to be anything special. It's just meant to be a feldspar, and particularly the plagioclaise, sodium and actually calcium plagioclaise. And so, why is that so? Which is not meant to be. So, the technical term, so the sodium feldspar is called albite, and the calcium feldspar is called anorthite. Okay, and it is like silicon dioxide or even opal, really, that they're a three-dimensional structured silicon dioxide mineral. And so it's not as good as opal because it just has the blue and the yellow mainly. And so what this one's doing is it's actually thin layer interference. So because there's a layer there, it reflects and concentrates, refracts and concentrates light. And so they've actually done like this here. They've actually gone in and seen little layers and measured them all out and everything. And so it is what you'd expect of structural color. It's around 100 nanometers, and they're alternating layers of calcium and sodium rich feldspars. And that's just in that area there. And so that's nothing to do with it. And that's just a large, sort of large panning out. And so it's just that little bit there. All right. And maybe could go down a few layers, and you've got to cut it and find it, and not take away the important layer, which is this unusual formation here. Okay, and the only other cool thing you can actually do is you can actually cut it on the edge and curve it round. Instead of just getting the yellows and the blues, you can actually get a little bit of a rainbow. But as you can see, it's not like opal where it's all colors at all different angles. It's just the same color no matter what angle you're looking at. But still pretty cool. All right.